Yeah, we should be live now. Just doing a sound check. Also check the different text to speech quickly. So this is the Google one.
ChatGPT, Advancing Neurotechnology, the Impact and Ethics of AI-Enhanced Brain-Computer Interfaces. Introduction to Brain-Computer Interfaces, BCIs. Brain-Computer Interfaces, BCIs, establish direct communication channels between the brain and external devices, translating neural signals into commands that can control various technologies. These
Yes, that was Google text to speech. This is a Microsoft text to speech of the same thing.
Advancing Neurotechnology, the Impact and Ethics of AI-Enhanced Brain-Computer Interfaces. Introduction to Brain-Computer Interfaces, BCIs. Brain-Computer Interfaces, BCIs, establish direct communication channels between the brain and external devices, translating neural signals into commands that can control.
So that's a bit better than the Google one. So Microsoft's is better than Google, that's for sure. And this is the OpenAI's one.
Advancing Neurotechnology, the Impact and Ethics of AI-Enhanced Brain-Computer Interfaces. Introduction to Brain-Computer Interfaces, BCIs. Brain-Computer Interfaces, BCIs, establish direct communication channels between the brain and external devices, translating neural signals into commands that can control various
good luck
technologies.
to all
These systems hold
podcasters.
the potential not only to restore lost functions, but also to enhance human capabilities
This
beyond our
text to
natural
speech
limits.
is almost
The
perfect.
role of AI
I
in
don't know how you
enhancing
can do it any better.
BCIs. Artificial intelligence, AI, is playing an increasingly
So this is
pivotal
a new
role in
blog
the evolution
that's
of
coming up
BCIs.
on the
By applying
website.
machine learning algorithms, particularly large language
My
models,
voice sounds more
LLMs,
robotic than this
AI
one.
can analyze the complex data generated by BCIs, improving the accuracy and efficiency of these systems. For example, AI algorithms can help refine the detection of neural patterns associated with specific motor commands or sensory inputs, thus enhancing the responsiveness and utility
Yeah, I
of
don't know where it
BCIs.
got the motor commands from. I didn't
Examples
ask
of
for it.
AI BCI integration.
Yeah, I did ask for seizure
1.
prediction.
Seizure prediction and management. AI-enhanced BCIs have made significant strides in the field of medical neurology, particularly in predicting and managing epilepsy. The University of
It's always.
California, San Francisco, UCSF,
I'm pretty
has
sure that
developed a
before it was
system
saying
where AI
MIT, now it's
analyzes
saying
EEG data
University
to
of
predict
California.
seizures before
Just
they
making
occur,
up stuff.
allowing preemptive medical intervention. This not only improves patient safety, but also enhances the quality of life for those living with epilepsy.
Yeah, that's generic. It doesn't
2.
need the
Motor
university name
function
there.
restoration.
There's many groups that
Groups
were
like the
doing the same
BrainGate
research.
Consortium have integrated AI with BCIs to enable individuals with paralysis to control robotic
So that's a
limbs or
legit
computer
group. I did
cursors directly with their
check
thoughts.
for that.
AI algorithms process the neural signals detected by the BCI to determine the intended movements, translating thoughts into actions with remarkable precision. The importance of open and transparent data.
Yeah, that's the one
The
I
advancement of
primarily asked
AI
for.
BCI technologies relies heavily on the availability of diverse, comprehensive data sets. Open data initiatives are crucial because they foster innovation. By sharing BCI data openly, researchers across the globe can collaborate more effectively, accelerating technological advancements and innovation. Ensure bias mitigation. Open datasets help ensure that AI systems are trained on diverse data, reducing the risk of bias and improving the generalizability of these technologies. Increase accountability. Transparency in data usage and algorithmic function allows for greater scrutiny and validation of AI BCI systems, building public trust and ensuring ethical compliance. Ethical considerations of AI BCI technologies.
Why these paragraphs
The
are
integration
too
of AI
short?
with BCI technology introduces several ethical challenges that must be addressed.
Must be addressed.
Privacy and consent. As AI BCI systems often handle sensitive neural data, ensuring the privacy and security of this information is paramount. Users must be fully informed about how their data will be used and must consent to these uses explicitly. Dependence and autonomy. There is a risk that individuals may become overly dependent on AI BCI systems, potentially impacting their autonomy. Ensuring that these technologies enhance rather than reduce individual autonomy is a key ethical consideration. Accessibility and equality. As AI BCI technologies advance, it is crucial to address issues of accessibility and equity to prevent the emergence of a neurotech divide, where only certain segments of the population benefit from these advancements. Conclusion. AI-enhanced BCIs represent a frontier in neuroscience and technology, offering profound benefits for healthcare, rehabilitation, and human augmentation. However, the successful and ethical development of these technologies requires a commitment to open data practices, collaborative innovation, and rigorous ethical standards. By embracing transparency and prioritizing user privacy and autonomy, the future of AI BCI can be both groundbreaking and globally beneficial, ensuring that these advanced technologies are developed responsibly and inclusively.
Groundbreaking and globally beneficial. Yeah. Oops. Yeah, we can go use less sensational. Use less sensational language. Use less. Must be using the wrong. 1 2 1 2. Testing. What's up with that? It's using use less sensational language. Remove words like okay, let's see what else. Right, so relevant references, it actually found quite a few. The BrainGate could have. Why did it use the. Yeah, it's a bit. Writing text is a bit like writing code, isn't it? Yeah, it's fine when it's searching for references, it's giving you different ones.
Advancements in artificial intelligence, AI, have significantly boosted the capabilities of brain-computer interfaces, BCIs, particularly in the area of medical applications such as seizure prediction and detection. Researchers have been exploring various machine learning techniques to enhance the accuracy and effectiveness of seizure prediction systems by analyzing EEG electroencephalogram data. For instance, AI-enhanced BCIs use advanced algorithms like stacked autoencoders, which are capable of feature extraction from large amounts of unlabeled EEG data. This technique enables the system to bypass the time-consuming and labor-intensive process of manually engineering features for each patient. Such
What?
approaches not only streamline data processing, but also adapt to the unique neurological patterns of individual patients, thus improving the predictive accuracy of seizure events. 37 source. Moreover, cloud computing plays a crucial role in the scalability and accessibility of these AI BCI systems. By utilizing platforms like Amazon Web Services, these systems can handle large data sets and provide high-performance computing necessary for real-time monitoring and prediction of epileptic seizures. This setup allows for extensive data storage and rapid processing, which are essential for the real-time application of BCIs in clinical settings. 37 source. Open and transparent data sharing is another critical aspect of furthering research in this field. Initiatives that encourage the open sharing of EEG data and research findings enable a broader base of researchers to collaborate and innovate. This openness not only accelerates the pace of technological advancement, but also helps in addressing potential biases in AI models by ensuring they are trained on diverse data sets. Open data projects contribute to more generalized and robust AI systems, which are crucial for applications in heterogeneous populations. 36 source. These developments underline the importance of integrating AI with BCIs to create more effective, responsive, and adaptable medical tools. However, they also bring forth ethical considerations concerning data privacy, patient consent, and the autonomy of individuals using such technologies. Ensuring that these technologies are developed and deployed transparently and ethically will be key to maximizing their potential while safeguarding user rights.
Yes, this is a legit link. It's using it twice. Then you have a second one as well, which does work, but I actually don't want to refer to that paper, or don't want to open it. Might be some potential conflict of interest there. So using PCA, primary component analysis and independent component analysis. Do they actually spell out? They should be. Sorry, not primary, principal component analysis. Yeah, bad name. So talking about dimension reduction, yeah, which is very important. You get a lot of these models that use like thousands or tens of thousands of parameters. You need to reduce the number of parameters. PCA can do that. ICA is independent component analysis and infinite independent component analysis. Sounds like a mouthful to me. Yeah, we like these things because we want to turn them into tools where instead of text you can just see some data, example data, scroll through different controllers and actually see what it does. Yeah, definitely no equations like that because no one actually understands what they are. The encoder from the autoencoders have been used to extract features. Yeah, I don't know why. It's just the same images there. It's not a great image, is it? What it is? Little things, and then encoder 1 looks exactly like encoder 2, looks exactly like this softmax thing, which I don't even know what it is. Input. So you have some. That's actually quite useful stuff like that, because I'm pretty sure any LLM, GPT-4, whatever, can generate decent code out of this pseudocode. So that's quite handy. Now this image here, this is a comparison of interictal baseline IEG segment on top, which does look okay. Could have been shifted, normally shifted around 0. Normally do like filter DC out of it. That looks legit. And then the pre-ictal before seizure IEG, intracranial EEG segment on the bottom. Like there is no way this is any EEG. It's not pre-ictal, it's not nothing. This is is that time? The samples. Looks like samples to me. It's the sampling rate, I don't know. Anyway, it could ever be, doesn't really matter, it could be 50 hertz, it could be also like impedance measurement artifact. But it's definitely not physiological, even though you have stuff like that, a little DC shift there, but it's not physiological, it's an artifact. So there's no chance that's correct. Results. American Epilepsy Society. Proof of concept prototype. Yeah, this is definitely proof of concept. Now, the title uses the word big data, big EEG data. Are they using this word anywhere else in the article? Yeah, they use it 21 times. So I suggest this is big data set. Now the confusion matrix, the performance essentially of the algorithm. Yeah, the diagonal elements use show the correct decisions. So this correct decisions there. 56, 57. They had 60 essentially interictal samples and 60 preictal. It's like there's no way in the world this should be called a big data set. It's not even medium. It's not even small. It's like it's like extra small. Yeah, I don't know why they jump into. Let's read this quickly.
The confusion matrix of the proposed method is shown in table I. To evaluate the classification ability of the proposed unsupervised feature extraction, the EEG feature sets are used for classification by other methods listed in table 2. The extracted features are based on fast Fourier transform, general energy average, and energy STDV over time for each channel, power spectral density correlation coefficients, partial directed coherence of the coefficients, power in band, low gamma phase sync, and log of energy in different frequency bands for each channel, 28. Experimental results in table 2 show that the proposed deep learning method outperforms previous methods for the EEG seizure prediction task. The feasibility of using cloud computing is analyzed by the network latency offered by Amazon EC2 cloud servers. The round-trip time, RTT, for servers located at different geographical locations, Virginia, Oregon, Singapore, and Ireland, is calculated for 64 BEEG segments at 10 days using the ping command. The shortest RTT is 15 milliseconds for Virginia server, and the longest RTT is 97 milliseconds for Oregon server.
Okay, yeah, using the ping command. Yeah, we discovered the ping command. Great. Okay. Valid classification. Well, first, I'm pretty sure I've seen other papers that use the random forest, linear SVM, nonlinear SVM, other neural networks, and achieved much higher accuracy. So I don't know where they got them so low. So they, selected a few studies and said how theirs is much higher accuracy. Yeah, you really need to. So that's false positive rate, false negative rate. Great. It's pretty small, but yeah, I suspect the choice of the other studies or algorithms is not great. Yeah, those are all legit feature. Fourier transform. So we have Fourier transform on our website. Go check it out. We have it probably in couple of places. Well, any time series converting to frequency domain would be using Fourier transform. So it will be all these tools, that one. This is, by the way, also intracranial EEG. Yeah, there will be an FFT in there. This is actually what a seizure should look like. Can increase the window size, see the whole thing. Yeah, so that will be before seizure EEG. So it definitely should not look anything like that. It's just something really wrong. Pretty sure this paper was not published anywhere. This is a preprint. It's just interesting that obviously, because it's a preprint, it's the good thing about it is that it's available in the public domain. Maybe the data set is available in the public domain as well. I don't know. But yes, I'm more than happy to cite it, but there's no point going over it. because it's obviously there's some major mistakes in it. Yeah, the problem with that text to speech is it's really good. The voice is just perfection. But then the way it's being implemented, I can't control the rate of it. I actually have a couple there. Speech, yes, obviously they will be adding more controls there later. It should have rate of speech, speed, and other things. Yeah, there's a bunch of them. That curve is pretty good. And the other problem is that I can't just highlight certain text and read it out loud. I can only read the whole response. These are keywords.
Here are some keywords that encapsulate the themes and subjects we've discussed in this conversation. 1. Brain-computer interfaces, BCIs. 2. Artificial intelligence, AI. 3. Seizure prediction. 4. EEG data analysis. 5. Neurotechnology ethics. 6. Data privacy and security. 7. AI in healthcare.
Yeah, that's
8.
so
Open
legit.
data initiatives. 9. Machine learning algorithms. 10. Cloud computing in medicine. 11. AI bias and fairness. 12. Neurological monitoring. 13. Patient autonomy. 14. Real-time data processing. 15. Stacked auto-encoders.
Yeah, that all sounds legit. We also have application. Yeah, we added another one there. It actually does speech production and intracranial EEG. I was talking to a so-called expert that said that that the AI there is picking up on artifacts from muscle and not the EEG itself. Well, I don't know. This is in nature. You would assume it was controlled and checked. These patients had implanted electrodes, SCG. So they will be picking up way less a muscle artifact in theory. Can ask the bot to comment on that. BrainGate, where's that one? Yeah, it's always resorting to using like UCSF or something. Well, yeah, there's a good reason for it. Sometimes it is hallucinating though. There's no links. It's only placing these links don't work. A BrainGate does work, and that's a legit website. So that's good reference there. But we need more. Yeah, we need reference essentially every time something like this is mentioned. Even though I'm pretty sure in this case we don't actually need the reference. Let's just quickly read it once more, see what's what.
Advancing neurotechnology, the impact and ethics of AI-enhanced brain-computer interfaces. Introduction to Brain-Computer Interfaces, BCIs. Brain-computer interfaces, BCIs, create direct communication channels between the brain and external devices, translating neural signals into commands that can control various technologies. These systems hold significant potential for restoring lost functions and enhancing human capabilities. The role of AI in enhancing BCIs. Artificial intelligence, AI, plays a crucial role in the development of BCIs by analyzing the complex data these systems generate. Machine learning algorithms, particularly large language models, LLMs, improve the accuracy and efficiency of BCIs. AI helps refine the detection of neural patterns associated with specific motor commands or sensory inputs, enhancing the responsiveness and utility of BCIs. Examples of AI BCI integration. 1. seizure prediction and management. AI-enhanced BCIs have significantly improved in predicting and managing epilepsy. Researchers at the University of California, San Francisco, UCSF, have developed systems that use AI to predict seizures by analyzing EEG data, allowing for preemptive medical intervention. This application improves patient safety and enhances the quality of life for those living with epilepsy. 2. Motor function restoration. The BrainGate Consortium has integrated AI with BCIs, enabling individuals with paralysis to control robotic limbs or computer cursors directly with their thoughts. AI algorithms process neural signals detected by the BCI to determine intended movements, translating these thoughts into actions with remarkable precision. The importance of open and transparent data. Open data initiatives are crucial in AI BCI development as they foster innovation. Open sharing of BCI data allows researchers worldwide to collaborate more effectively, speeding up technological advancements. Ensure bias mitigation. Open datasets help ensure AI systems are trained on diverse data, reducing the risk of bias and improving the system's generalizability. Increase accountability. Transparency in data usage and algorithmic function builds public trust and ensures ethical compliance. Ethical considerations of AI BCI technologies. Integrating AI with BCI technology introduces several ethical challenges that must be addressed. Privacy and consent. Handling sensitive neural data with AI BCIs requires robust privacy protections and informed consent from users. Dependence and autonomy. There is a risk that individuals may become overly dependent on AI BCI systems, potentially impacting their autonomy. Accessibility and equality. Ensuring that AI BCI technologies are accessible to all is crucial to prevent a divide where only certain segments of the population benefit from these advancements. Conclusion. The development of AI-enhanced BCIs offers significant potential for improving quality of life, particularly for individuals with medical conditions like epilepsy. However, the success of these technologies depends on adhering to stringent ethical standards and ensuring robust safeguards are in place to protect user privacy, autonomy, and fairness. By addressing these challenges proactively, the field can ensure that the development of BCIs is both responsible and inclusive. For further reading on AI-enhanced BCIs and seizure prediction,
Yeah, can we suggest alternative title? Also, can we generate the list of relevant keywords? Also, can we generate a separate reference list that covers any items in the text, including the link? Obviously, that should be a working link, not just, yes, sometimes it does hallucinate links, but that's okay. What was the original?
Advancing Neurotechnology, the Impact and Ethics of AI-Enhanced Brain-Computer Interfaces. Exploring the integration of AI with brain-computer interfaces, enhancements, ethics, and open data.
Yeah, the second one sounds much better. What do we have for keywords?
Brain-computer interface, BCI, artificial intelligence, AI, seizure prediction. EEG analysis, ethical considerations, data privacy, machine learning, open data, neural signal processing, accessibility and equality.
Yeah, the previous list sounded better than this, but this one is shorter. Should be okay. Now only this one link actually works. The other ones do not. Why? Only the second BrainGate link works. The first and the verb do not work. Yep. 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 Yep, yep, yep. Yep, 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 yep. Oh, come on. Should have been... Right. This got erased. Yep.
I apologize for the inconvenience with the links. Here's the corrected reference list with operational links for further information. 1. BrainGate's motor function restoration. Explore how AI-integrated BCIs are enabling individuals with paralysis to interact with their environment at BrainGate at www.braingate.org. Unfortunately, I wasn't able to verify the specific UCSF link and the Frontiers in Neuroscience article directly in the browser. For accurate and detailed information on AI-enhanced BCIs for seizure prediction and the ethical considerations, I recommend checking directly on reputable medical and neuroscientific research databases like PubMed, IEEE Explore, or directly on university research portals like UCSF's official site. These sources are rich in peer-reviewed articles and provide comprehensive insights into the latest advancements in the field.
I don't particularly like IEEE. Clear. Yeah, Google Scholar should be fine as well. Is it being lazy? But yeah, I need the links in the text and at the bottom of the article. TPU at the end. It's Science Daily. No, I don't like Science Daily. Is that even legit? Artificial intelligence gave paralyzed me on her voice back. Yeah, I don't like this pop. Don't even like the title of the article, but if there's a link to the actual, there's a YouTube video. We love YouTube videos, but yeah, might leave that one aside for a sec. Okay, those legit. Science Daily, no. BrainGate, okay. There's only 2. Oh, come on. Further reading. Okay, I think it's just being a bit lazy. I need the full article. Don't remove anything. Make sure there are links throughout the text and a reference list at the bottom. There should be definitely more than 2. 5 to 6 will be great. Make sure links are included. Yep. Yeah, and we might jump to something else. Let's check our list. Yeah, we have this whatever BCI AI a blog that will pop up on biomedical sometime soon. What else we got? Over the weekend, just to take a break. Over the weekend, we're doing this a game of life simulation thingy. So let's quickly go over it. Maybe we can actually get it to work. There were some silly errors that I was getting. We could possibly get sorted. By the way, I now remove those live streams, ones that haven't been it was the criteria, whatever. If they had less than 10 views and they from several months ago, they just get removed. Eventually I make standalone videos if something interesting happen, and to increase the chance of something interesting happen, you actually need to participate, ask questions, go live together, so on and so forth. Because just my voice and screen might be way too boring. Anyway, we have this a game of life, a simulation. It was actually one of the better. Do we have? Yeah, something there. It wasn't working. We had the chat for it. I should normally put like a link to my GPT-4 chat. Just quickly check on another screen. Yeah, Flask model of Game of Life. That should be it. And again, we were looking for like the best implementation of it. Did find one that was pretty good. So it was a bit old, so it wasn't actually working properly. I wonder, yeah, this chat was from 2 days ago, 1 day ago. I wonder if you can just continue the same chat, because now GPT-4 added memory to the mix, but I don't know how it actually works. It seemed to work because it just keeps generating. Yeah, this one does like a full game of life simulation. So if you don't know what it is, go check it out. There's some amazing. Yeah, I'll pull out the best one that I could find. It was to search for it, but I yeah, probably don't want to look at it too much because mine will end up looking the same or something. That's not good. So primarily in a Flask application, we're trying to rely on JavaScript as much as possible. And yes, I can do stuff in the backend currently, but yeah, trying to not overload my server. So there's currently not much is happening at the background. So I need the style CSS. We have HTML. We'll run the application in a second. I don't think it's working at the moment. Well, because the code is not complete. Function category P5. Yeah, we're using P5. Where's the content? Where's the event listener? We should have event listener. If we don't have event listener, it's not the full code.
Below is a complete and functional JavaScript code using the P5 JS library for your interactive model of life. This code incorporates all required functionality, including dynamic grid resizing, material application with mouse events, and grid updates for simulating different materials like sand, water, rock, and life.
Yeah, rock and life. Yeah. What else should we add? Neurons. Life, neurons. How many? Yeah, we'll get to it in a sec.
Instance mode. The code is wrapped in an instance mode closure new P5 function P to encapsulate all P5 JS functions, variables, and behaviors. This ensures that your code runs only after the P5 JS library has initialized, preventing errors related to undefined functions. Dynamic grid size. The grid size adjusts dynamically based on the slider input. When the slider is adjusted, update canvas size is called resizing the canvas and reinitializing the grid. Material application. Mouse events, mouse pressed and mouse drag, apply materials to the grid. This checks if the mouse coordinates are within the canvas bounds before applying materials. Continuous simulation. The draw function checks every 10 frames to update the grid, simulating the movement of sand, water, rock, and life according to specified rules. Visual representation. Show grid visually represents the grid, drawing each cell according to the material type, colored appropriately by getColor.
It's doing something. Yeah. It's always like that. Is that there's something missing? Okay, we need to update. Can we regenerate, update that HTML code? And also currently we have the CSS script missing. Can you generate that as well? Yep. Yeah, but that's the idea of it, is that you can select different stuff. Currently they're all doing the same. Obviously the code is not complete. Yeah, we need to update HTML quickly. HTML. Why did you put the styling into the HTML? That's fine for now. they have that Ajax B5.js. We should also have our main JavaScript. Where is it? Where is it? Let's pop it in there quickly. Where we call JS, we should also call our own JavaScript. Have the styling in the HTML as well. Not ideal, but okay for now. Sand. What on earth? What on earth? Oh, that was too loud. It's shut up. The camera shutter scared the hell out of me. Okay, we might have not complete code because it's only doing sand, no other materials. So something must be missing. There's no life. Here's currently what we have for the code. How to fix exactly so the application is functional. Yep. Is it hallucinating stuff or no? We do have that application. Let's do a console log inside it, and let's format the whole document. See if we get any errors in the browser. Looks like yes. Main.js. That's a problem, isn't it? It's in the static folder, yes, but why can't I find it? What are you talking about? This is the jobby for GitHub Copilot. Select the whole code, give it the error message saying in the case main.js could not be found, or like what. Didn't actually fix anything. Why? Server configuration. Nah. There's no bloody server configurations. No, there are server configuration. There are no problems with the server configuration. Main.js is not found. Come on. Silly, silly, silly goose. The easiest thing would be to create relative path. Call static main.js. Okay, that meant to be a static folder. What are you doing? There should be shortcuts for the different materials. Why there's a canvas? We don't need that canvas. Yeah, we're not calling it anyways. You can get rid of it. It's only doing sand. Sand is not falling. Destroy is not working. Destroy, destroy. I don't know, is it even related to biomedical engineering? Console log inside the not working. Clear, 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 clear. Let's check the settings. Stop, clear, clear when I say clear message input when I say clear. Clear. Doesn't work. Clear. It does work. Clear. Okay, a couple of things. We only have sand at the moment. Even if I select a different material, sand is being placed. Also, sand meant to be, I guess, dropping to the bottom of the canvas, as opposed to rock that should just stay where it is. Also, make a comment if this is relevant to biomedical engineering. Yep. To fix that code. Something obviously very wrong with that. Display grid size doesn't do anything. There's no life. There's no life. Well, I mean, it's related to biomedical engineering because there is life, meant to be life, meant to generate life. Clear.
It sounds like there might be a bug in the apply material function where it isn't correctly switching materials based on the selection. This is probably why only sand is being placed regardless of the selected material. To fix this, ensure that the apply material function reads the correct value from the selector and applies the correct material to the grid. Here's how to adjust this function.
Okay, why didn't you generate this function properly to begin with?
This ensures that the material selected from the dropdown is correctly applied to the grid. Regarding the behavior of sand and rock, sand should fall down the grid towards the bottom until it encounters an obstacle. Rock should remain static where it's placed unless moved by another process. Relevance to biomedical engineering. Simulating different materials and their interactions can be relevant to biomedical engineering, particularly in areas like tissue engineering where understanding cellular environments is crucial. Modeling how different cells or materials interact can help in designing scaffolds that mimic biological tissues. Additionally, simulations similar to sand or water flow can help in understanding fluid dynamics in biological contexts, such as blood flow or the movement of other bodily fluids.
A material is still not switching properly. Can you fix the code? Here's also the HTML just in case. See what it does. While it's generating, go check out biomedical.com. There's quite a few interesting tools. This was the last one that is, I don't know what that was. It's something in the camera. It's not part of the tool. This one's simulating different types of vision impairment. Go check it out. There's a description at the bottom, and let me know which other vision impairments would you like me to add to this simulation.
To address the issue of materials not switching properly in your P5.js application, it's important to ensure that the material selection is being correctly read and applied when the mouse interaction occurs. Let's verify and correct the function that handles material application based on user selection from the dropdown. First, ensure your dropdown cell is properly linked to the DOM and actually captures changes. It's a good practice to log the selected value to make sure it changes as expected.
What do I currently have? Cell. No, that's some troubleshooting as well.
Ensure that apply material correctly interprets the dropdown's current value each time it is invoked. This function should be triggered within your drawing loop or via event handlers, mouse interactions. Make sure that the mouse pressed and mouse dragged functions are correctly applying materials based on current selections. This means they should call apply material without passing the material directly, but instead letting the function determine it based on the current drop-down value.
Don't have this function. I'm not even calling this function. What are you hallucinating about?
After making these adjustments, thoroughly test each material type to ensure it's being applied correctly. Look out for any console logs or errors in the browser's developer tools, F12, console tab that could indicate issues with script execution or logic errors. With these corrections, your application should properly handle different materials based on user input, ensuring that each material type can be applied and functions as intended within your grid. If issues persist, consider isolating the problem by testing one material at a time and checking for any overriding settings or errors in console logs.
What do we currently... do I need the mouse press and mouse dragged functions? Currently, I don't have them. There is a mouse is pressed function, but that's something else, is it? Yep.
In your current setup, the P5.js framework handles the mouse pressed and mouse dragged functions inherently within the instance mode sketch you set up. This means you do not need to explicitly define separate functions for these unless you need to customize their behavior beyond what you've currently implemented. The if p mouse is pressed condition within
In your current setup, the P5.js framework handles the mouse pressed and mouse dragged functions inherently within the instance mode sketch you've set up. This means you do not need to explicitly define separate functions for these unless you need to customize their behavior beyond what you've currently implemented. The if p.mouse is pressed condition within the p.draw function effectively checks if the mouse button is held down during each frame of the draw loop. When this condition is true, it executes the apply material function, which applies the selected material at the mouse position. This achieves a similar effect to handling mouse pressed and dragged events separately. If you need to customize behavior when the mouse is clicked or dragged, for example, to start or stop an action only when the mouse is clicked, not when it's held, you might then need to define p.mousePressed or p.mouseDragged explicitly. For basic functionality where you are applying materials wherever the mouse moves while pressed, your current implementation is sufficient. Here's a short guide on when you might want to use these functions. p.mousePressed. Define this function if you need something to happen exactly at the moment the mouse button is clicked. p.mouseDragged. Use this function if you need to handle continuous input as the mouse moves while a button is pressed. If everything is working as expected with your current use of if p.mouse is pressed inside the pdraw loop, and you do not need any additional mouse interaction handling, you do not need to change anything. If you find that you need more control over mouse interactions, consider implementing these functions to handle specific actions during mouse press and drag events.
but the materials are still not switching between them. How to fix? Yep.
If the materials in your simulation are not switching properly when selected, it likely indicates an issue with how the selected material is being retrieved or applied in the apply material function. Here are some steps to diagnose and fix this issue. Ensure that the ID used in cell, parent, material select matches exactly with the ID of the container in your HTML. Any discrepancy here would mean the dropdown isn't properly displayed or functioning.
No, those are fine.
In some cases, invoking functions directly inside the draw loop without proper conditions might lead to unexpected behavior. Ensure your logic only applies material if a mouse event actually occurs within the canvas bounds.
It keeps going for the if mouse pressed, which don't need this function, do I? I already have draw. Okay, we're getting stuck here. We are getting stuck here. Having still the same problem. Here is the updated code. Oh, by the way, GPT-4 changed a few things. They now don't actually have the numbers for the limits for per hour of how many prompts you can do per hour, but they do say usage limit may apply. So I guess depends on the how heavily it's being currently used or not. Clear. Okay, in HTML we need to check and want to destroy. That's fine. Material select, ensure the container is present. Yes, it is present. grid size. Material select. Okay. Why do we have it twice though? See sand. Okay, we have water. We have rock. Life. This is life. Destroy. Wait, is destroy? Yeah, destroy is working. Life. It's also destroying. Oh, Okay, couple of things. Let's actually keep that in there. Have a robot separately. Okay, a couple of things. Water is not falling down. Sand is not falling down. Rock works okay, so it stays where it should. Destroy is working perfectly well, but then life seemed to also destroy. So not sure what's up with that. Also not sure why we have two drop downs. Can we quickly fix that as well? And here is the current code that we have. Let's also see, I also want to see when will we hit the limit of this session. Clear.
To address the issues you're experiencing with the behavior of materials in your simulation and the double drop-down problem. Water and sand not falling. Ensure that the rules governing the movement of sand and water check not only for an empty cell directly below, but also potentially for water displacing sand and vice versa. This might involve adjusting the order of checks and actions in your update grid function. Life behaving like destroy. This suggests that the rules applying to life might incorrectly cause it to be erased. Verify that the conditions under which life is supposed to sustain or grow are correct, particularly how you count neighbors and apply the game of life rules.
It's still not falling. Oops. Life is still destroying.
From your code snippet, it looks like you might be accidentally creating two select elements or not clearing the previous select input before reattaching it. Make sure you only create one select input and properly attach it. HTML update. Remove any extra select element directly written in HTML if you're creating one dynamically in JavaScript. JavaScript update. Ensure you're not duplicating the creation of the select element. If the select element is already created in HTML, just reference it instead of creating a new one in JavaScript.
Okay, same problem.
Check if this resolves the problem of duplicate dropdowns. If issues persist, consider isolating the dropdown creation logic and ensure it runs only once or is properly cleared each time before being recreated.
Okay, this was a beta. Grid size doesn't change. Destroy works okay. Water meant to generate life. It also meant to fall to the bottom of the screen. Sand also meant to be falling to the bottom of the screen. Meant to be falling to the bottom of the screen. Grid size doesn't change. The controller of grid size doesn't actually do anything. There's still two drop downs. Is there any simple way of getting rid of it? Seems like the second is working okay. The first one is not doing much. Here's the updated code. Yep.
It looks like there are several issues to address in your simulation.
Okay, that's so wrong language. What language is it? Ah.
Sand and water behavior. If sand and water aren't falling as expected, ensure that the logic for handling their movement respects gravity and other materials' presence. The conditions in handle sand and handle water functions seem correct, but ensure they're triggered properly within the update grid function. Life behavior. If life behaves like destroy, it could be due to how life cells are updated.
It's flowing
Ensure the
somewhere.
rules for life, from Conway's Game of Life, typically, are correctly implemented. Life should only be destroyed if it has fewer than 2 or more than 3 neighbors. Adjust the logic in update grid to correctly handle life creation and destruction. Grid size slider. If the grid size slider isn't affecting changes, check the update canvas size function. Ensure this function is correctly recalculating the grid size and reinitializing the grid and canvas based on the slider's new value. Duplicate dropdowns. It seems you might be creating a dropdown in JavaScript and also directly in HTML. You should choose one method. If you're initializing it in JavaScript, remove the HTML dropdown. Make sure your cell, parent, material select targets an existing empty div, not one with another select inside.
Again, remove this one, can I? Instead of that, just have the material select. Sand. What on earth? It's only happening with no. Is that intentional? Don't think so. Destroys and then what? JavaScript, let's check that. The cell create select. Yeah, we have it in there. Oh, that's working. There are other errors. No, that's fine. Okay, sand and water. Sand and water doing this weird thing when you place them. They also get placed in a mirrored location. See image attached. Also, sand and water are not dropping down as they should. Rock is working well. Yeah, I guess that the mirrored location for the water is where it's an attempt for it to actually flow towards the bottom of the screen based on gravity. Same with sand. Rock can stay where it is. So that's one working okay. Yeah, destroy works okay. But live is doing something. So live meant to be doing the rules of the game of life. It meant to be generating new life around water. I think the color of it is black, so I can't potentially see it. Can we check test for that? Here's the code again, just in case. Yes, we have a mirror issue. Sand water not falling, handle, sand handle water. Conceptually correct for handling gravity, however. No, they are not. Actually hold the movement when encountering another material. Let's start. Um, Color visibility, update grid. To make sure update grid does the correct colors and stuff. So we have a potentially better version of it. Mm-hmm. Yeah, it's not right. Obviously rock. It doesn't do it. Okay, now sand does this weird thing. If it's flowing somewhere, I can't see it. Destroys okay. Can't even take a screenshot of it because I need to move the mouse for something to be visible. Yeah, life. It changed the color of life. Okay, we have something running. Still has that mirrored thing. It's meant to be life around water. Water meant to be flowing. So for example, if you have a rock here, so water meant to be flowing down like that. somewhere in the code we have that is life destroying rock, looks like. That should not be the case. Okay, a couple of things. We seem to have life destroying rock. We have this weird mirror effect where life, water, and I think sand as well are appearing on both sides of the screen. Can we make sure water and sand are actually flowing downwards as per gravity? They should also interact with the rock. Can we also make sure that where water is generated, there is also life generated around it? Yep. I have to go over the rules of life. Should the rules of life be?
From the image you shared, it appears that there are issues with elements mirroring across the canvas and behaviors like sand and water not flowing as expected due to gravity. Here's how to address these. 1. Preventing mirroring across the canvas. This mirroring effect might be due to an error in how coordinates are calculated or a wraparound error where changes on one side of the grid unexpectedly affect the opposite side. Verify that your array indexing and modifications are confined within expected bounds. 2. Ensuring gravity affects sand and water. Both sand and water should move downwards if the space below them is empty or contains a lighter material. Water can push sand, but not rock. Here's a refined approach for handle sand and handle water. To ensure that life spawns around water, you might adjust the conditions in your update grid method. Make sure the color used for life contrasts well against the background and other elements, and check the logic that updates life to ensure it's not incorrectly overridden or erased during grid updates. Implement these solutions, then carefully test each change to ensure they behave as expected. Adjustments may be needed based on specific interactions or additional requirements of your simulation.
And it's only doing it on one side of the screen, not the other. Why is it behaving different? Something weird. Meant to flow. The coordinates need to make sure. I suspect we might have to regenerate the whole code from scratch. Hey, can you do it for me? Yep. Let's see what we've got.
Certainly. Let's rebuild the code to ensure everything behaves as expected. Sand and water should flow due to gravity, life should spawn around water, and we need to ensure the grid updates correctly without mirroring issues. Here's a fresh approach, taking into account all the functionalities you need. This refactored version of your script includes handling for the behaviors you specified. Gravity for sand and water. Sand and water will now try to fall downwards. Life generation near water. When water is updated, it checks its neighbors and can potentially spawn life if the conditions are correct. Color visibility for life. Change the color to bright yellow to make it more visible. Stability for rock. Rock doesn't move, maintaining its position. I've also addressed the issue of life potentially destroying other elements by making sure that life behaves according to the simplified game of life rules you outlined, influencing its behavior based on its neighbors. Ensure you also correct any HTML issues to prevent multiple dropdowns or conflicting IDs that might cause JavaScript to behave unexpectedly. If there's anything else that needs tweaking or further explanation, let me know.
Also, can you regenerate the HTML code from scratch? Yep. Supposedly not counting neighbors properly.
This change ensures that the function does not attempt to access grid values outside of its defined dimensions, which is likely the cause of the undefined reading error. This HTML structure is cleaned up, ensuring that the select element is used correctly with a unique ID for easy access from your JavaScript code. If you're seeing two dropdowns previously, this setup should prevent such issues by having only one select with the proper setup for your interactive simulation.
Oh, come on.
These adjustments should help in smoothing out the functionality of your simulation, ensuring materials behave as expected and eliminating the JavaScript errors. If any more adjustments are necessary, feel free to ask.
Considering the HTML refreshed version of the HTML doesn't work as expected. Suspect the live stopped. Live stopped. Shall we start? Let's try a new chat. So it is a Flask application. We have index HTML and JavaScript. There are a few issues with this code. Water and sand are not behaving as expected. I expect them to fall to the bottom of the screen. Rock is working okay. Life is not doing much. And also we need to make sure that life is created around where water is. Yep. So we started a new GPT-4 chat. See if we can improve the application. Suggesting to change how the sand is being handled. Currently there's not much to it. Handle sand. Oops. Handle sand, handle water. It's not moving.
If you want to model life, perhaps based on Conway's game of life, it seems like you need a more accurate simulation for creating and sustaining life based on certain conditions.
That's okay. Why? Handle water. To make sure it's used correctly. And the life is not complete. We also have apply material. Apply material function. So I'm going to destroy. Yeah, I want to place life near water.
This revised logic will allow you to place life only adjacent to water, providing a condition that ties the creation of life to the presence of water, as per your specifications.
Let's check for errors. There are no. Can we just go from images? So just gave it this image. It's obviously wrong. Let's see if it can pick up on what potentially might be wrong with it. That's right.
It seems like the water and sand aren't behaving as expected because they might be clumping instead of flowing. Here's a deeper dive into potential issues and improvements. Sideways displacement. It's good to see some horizontal displacement logic in your updated functions. If it's still not behaving correctly, you might need to adjust the priorities or the conditions for movement. For instance, water typically spreads out more than sand due to its lower viscosity. This can be modeled by checking more aggressively for sideways displacement opportunities for water. Update order. The order in which you update cells can affect the behavior of falling particles. Typically, updating from the bottom up, starting from the last row to the first, can help in simulating gravity more realistically, as it prevents overriding changes that still need to be processed further up the grid. Performance concerns. If you notice lag or slow updates, especially with smaller grid sizes, more cells to process, you might consider optimizing the grid update routine. One common method is only updating cells that have changed or are near changes, rather than the entire grid each frame. If problems persist, please provide more details about the unexpected behavior or share a screenshot showing the issue. This will help in diagnosing the problem more accurately.
Why is this? Ah. Right. Okay. Not exactly. Destroy. What? It's super weird. Nah, that doesn't look realistic, does it?
It seems like you've successfully created a simulation with distinct behavior for different materials. If there's any specific behavior or feature you'd like to improve or troubleshoot based on your latest simulation screenshot, please describe what you are aiming for or what issues you are noticing, and I can help refine or adjust the code accordingly.
Yes, the sand and water do not behave realistically The water also should not should flow, not behave like sand, like clumping into a pyramid structure. Sand should clump into a pyramid structure, but then it should be flowing grain by grain to the bottom of the screen and then piling up. Water should just be flowing. In other words, we need a more realistic model of sand and water. Also, bring back life. It's currently not doing anything. Rock is working really well. Yep. Yeah, not sure if it's quite relevant to biomedical engineering, but let me know what you think. Should it go on the Bionic Chaos website?
To improve the realism of your simulation, particularly for water and sand, and to make life behavior more dynamic, we need to refine their handling functions based on the physics of fluids and granular materials. Here's how you can adjust your model. For sand, which tends to pile up but also needs to flow grain by grain, we can enhance the downward and sideways logic to better simulate the granular flow. Water should flow freely and spread horizontally much more than sand. We adjust the logic to allow more horizontal displacement and less piling up.
That was no good, was it? But it's not. No, I get what it's trying to do. But it's not good enough. Back to the simulation of life. Not sure. So sand is behaving okay. A couple of things though. It should be first falling down grain by grain, and only when getting to the bottom of the canvas starting to pile up into a pyramid structure. Same with water. It should be flowing down, dripping down, drop by drop to the bottom of the page, and then flowing, spreading equally across the available surface. Life is still not there. So you should be able to create life when the life option from the drop-down menu is selected, but also life should be created around where water is. Please fix the following code. Yep. Probable.
Regarding your simulation suitability for biomedical.com, the use of a dynamic system like the one you're developing can indeed be relevant, especially if it's framed in a way that relates to real-world biological or ecological systems. For example, your simulation can be used to model the distribution of resources in an ecosystem or the spread of organisms in a habitat. The visual and interactive nature of the model can make complex concepts more accessible and engaging to your audience. Now, let's refine the simulation based on your requirements. Sand and water flow. You want both sand and water to flow more naturally to the bottom and spread out realistically. Life creation and dynamics. You're looking to have life appear more dynamically, especially around water, and behave according to a set of biological rules. Here's an adjusted version of your code with these specifications in mind. For both sand and water, ensuring they move naturally involves adjusting their movement logic to simulate gravity and lateral dispersion correctly. Sand should primarily fall downwards but disperse slightly upon reaching an obstacle. Water should flow downwards and spread laterally much more freely than sand. For life to be more dynamic and dependent on water, you might consider adjusting the rules for life creation and maintenance. Make sure that your update grid function and others properly utilize these adjustments. It's also crucial to test these changes to observe the dynamics and make necessary tweaks. This iterative process will help you fine-tune the behavior of sand, water, and life to achieve a more realistic and visually appealing simulation. Sand should primarily fall downwards but disperse slightly upon reaching an obstacle. Water should flow downwards and spread laterally much more freely than sand.
It's not working as expected. Can we redo the whole logic? Probably the whole JavaScript code. Let's try a different approach. can you generate all the prompts required to build the application based on the requirements in this discussion? Yep. While it's generating, go check out bionicchaos.com. There's a lot of interesting tools and you will be supporting the project that way. And don't forget to leave your feedback. Clear?
Sure, here are the structured prompts that can guide the development of your simulation, covering all the requirements and features discussed. 1. Set up the environment. Prompt. Set up a basic p5.js environment within a Flask web application. Ensure the p5.js script is properly linked and accessible. Initialize the drawing canvas and prepare the basic UI elements such as a material selection dropdown and a grid size slider. 2. Define materials and constants. Prompt. Define constants for the different materials such as sand, water, rock, life, and empty spaces in the grid. These will be used throughout the simulation to determine the behavior of each grid cell. 3. Grid initialization. Prompt. Create a function to initialize the grid. Each cell should start as empty. This grid will represent the space in which materials can be placed and interact. 4. Dynamic grid resizing. Prompt. Implement a function to dynamically adjust the grid size based on user input from a slider. This allows the user to modify the resolution of the simulation on the fly. 5. Material placement. Prompt. Develop a function that allows users to place materials on the grid by clicking on the canvas. The material placed should correspond to the user's selection from the drop-down menu. 6. Material adjacency check. Prompt. Create a utility function to check if a given cell is adjacent to another material, specifically water. This is critical for the dynamic creation of life in the simulation. 7. Sand behavior. Prompt. Code the behavior for sand in the grid. Sand should primarily move downwards but also disperse sideways slightly when it encounters an obstacle directly below. 8. Water behavior. Prompt. Develop the behavior for water, making it flow downwards freely and spread laterally much more than sand. Ensure that water can move around obstacles in a fluid-like manner. 9. Life dynamics. Prompt. Implement the rules for life based on a simplified version of Conway's Game of Life, where life can form near water if surrounded by exactly 3 living cells and can die from overpopulation or loneliness. 10. Simulation logic. Prompt. Create the main simulation function that updates the state of the grid based on the behavior rules of sand, water, and life. This function should be called continuously to animate the simulation. 11. Rendering the grid. Prompt. Write a function to visually render the grid on the canvas using different colors for each material type. This function will be crucial for visually debugging the simulation. 12. Optimizations and efficiency. Prompt. Consider ways to optimize the simulation, especially how the grid is updated and rendered to improve performance as the complexity and size of the grid increase. 13. User interactions and feedback. Prompt. Ensure that user inputs through the material selection dropdown and the grid size slider are responsive and affect the simulation immediately. Provide visual feedback for user interactions. These prompts cover the setup, implementation, and refinement of your simulation. ensuring that each component is addressed systematically to meet your requirements for a realistic and interactive model. Each prompt can be used as a milestone in the development process, helping you track progress and maintain focus on the key features of the simulation.
Here's a fresh implementation of the HTML, JavaScript, and CSS needed to set up your simulation based on the prompts and requirements we discussed. This implementation covers all the basic functionality needed to run your interactive simulation with the ability to adjust grid size dynamically, interact with the grid via mouse inputs, and manage different materials. Further development can focus on adding a specific behavior for sand and water flow, life dynamics, and other features as discussed.
Okay, the grid size now is working, but nothing else. What's that screen there? Simulation canvas. It looks okay, and the grid size is working. Material drop down is working, but not sure why do we have two grids, left and right. And also the drawing doesn't seem to work. So when I move my mouse on any of the grids, nothing appears. Can we check the code? Yep.
It looks like there might be a couple of issues with the interactive behavior of your grid, particularly related to detecting mouse events and updating the grid based on those events. It's possible that the drawing functionality is not responding because the draw function is set not to loop, and mouse drag might not be triggering redraws as it should. To fix this, you can make sure to call redraw within mouse drag to update the canvas immediately when the mouse interacts with it.
Yeah, we just pop this image and the code, see if it comes up with what might be wrong.
Great to see that the interaction with the grid is working and you're able to draw different materials. If you're looking to fine-tune the behavior further, especially focusing on the drawing interaction to ensure materials are being placed correctly as you drag, here are a few suggestions. From your description, it sounds like you're observing the correct behavior now, but you might want to ensure the drawing is smooth and responsive across all grid areas. If any part of the grid doesn't respond to the mouse drag, verify that the calculations for x and y coordinates in the mouse dragged function are correct. Adding console logs to trace the coordinates can help ensure the entire canvas is interactive.
It's pretty interactive, there's no problem there.
As you expand this simulation, especially when handling a larger grid, material interactions, for instance, water could dissolve, sand over time, or life forms could grow or die based on the availability of water. Simulation controls, add play, pause, and reset buttons to give users more control over simulation execution. Gravity for sand and water, implementing a simple physics model where sand and water fall and spread more naturally. Life propagation, adjusting the conditions under which life spreads or dies to make the ecosystem dynamics more engaging. Add update materials inside your draw function to see this effect in action. This simple model could be expanded with more complex rules for lateral movement and interaction with other materials.
And now we're talking. Okay, let's see if it can pick up on the problem, particularly with water. I like how sand. Yes, sand should not do that, should it? And life should do the life business. Do the life business. But it's much better than what we had before. Starting fresh helped a lot. Starting fresh helped a lot.
It looks like your simulation is evolving nicely, showing the behavior of different materials and how they interact within your environment. From the screenshots, we can see how materials like water and sand behave under gravity, and there's a visualization of.
It's not that it's being lazy, it doesn't want to generate code. We have update water, no.
Here's a simple pseudocode to enhance water dynamics. This code tries to move water downwards first, then left or right, simulating a more natural flow behavior. You can adjust this further to include diagonal movement or varying flow speed based on terrain or material type. These types of dynamics can make your simulation more engaging and visually interesting. Feel free to use these suggestions to further develop your simulation into a more complex and interactive tool.
Where do we use update water and update sand functions? It says anywhere. Also, how do we make sure life does the life business based on the game of life rules? Can we make sure the rules are implemented in the code? Yep.
To fully integrate and utilize your update water and update sand functions, as well as ensure the game of life rules are correctly implemented for life material, let's refine your update materials function and add a separate routine for life dynamics based on your specifications. Integrating water and sand update functions. Currently, your update materials function independently handles gravity effects for sand and water. Instead, you should utilize the update water and update sand functions you've prepared. Here's how you can integrate those. This ensures that update water and update sand are called and affect the simulation correctly, respecting the unique movement rules. To implement the game of life rules for the life material, you will need to add a function that updates the life cells based on their neighbors. Here's a basic implementation. Make sure to call update life in your main draw function to ensure it is processed every frame.
A couple of things. Life is not yet integrated properly. We need to fix the code. Also, with sand and water, can we make sure that when they spread, sand remains as pyramid? And the water spreads across the surface. However, we need to make sure there is no more grains or drops generated than was created by the mouse. Yep. Okay, let's see if it understands. Probably doesn't.
To enhance your simulation further and integrate the life material correctly based on the rules of Conway's game of life, as well as refine the behaviors of sand and water, we'll make several modifications and additions to your existing script. For sand to form a pyramid shape and water to spread more naturally, we need to adjust their respective update functions. To ensure no more materials are created than what was initially placed by the mouse. Integrate a control mechanism that keeps track of material placed and ensure it doesn't exceed a set limit or modify the behaviors to not generate additional materials beyond initial placement.
The problem with like context is a good practice of how to use GPT-4. Okay, nothing is drawing at the moment, so I don't know what the problem is. Also, can you create all the prompts that will recreate this web application? Include all the technical details. Yep. Okay, we're going in circles now. This is the third time we are regenerating this code. What's the function setup? Right, so it generated the whole code.
To assist you in identifying where your simulation may not be drawing correctly and to provide comprehensive guidance for recreating this web application with all technical details, here is a step-by-step breakdown and set of prompts for each phase of development. These will cover setup, initialization, core functionality, user interaction, and debugging strategies.
So in HTML, have a canvas container. Where is it? Right, now we have one grid. That's good. And no errors. That's great. Now in JavaScript. Have this set up. Keep it simple.
Prompt. Create a dynamic grid that initializes to empty and can resize based on user input from a slider. This grid will serve as the playground for various materials.
Okay, we have then grid initialization.
Prompt. Develop functions for mouse interaction allowing users to place materials on the grid, which updates in real time. Each material type should have unique properties and interactions. Prompt. Code specific behaviors for each material, how sand and water move under gravity, and how life interacts with its surroundings based on Conway's game of life rules. Prompt. Ensure that the grid is visually updated on the canvas after any changes due to user interaction or automated material behavior. Prompt. Listen to user input from a slider to dynamically adjust the grid size and redraw the canvas accordingly. Prompt. Implement console logs and validate that all functions are triggered correctly. Ensure materials are updated correctly and life forms follow the expected rules. Make sure all functions are correctly integrated into the setup, and draw functions to maintain the simulation lifecycle. These prompts should guide you through setting up, developing, and debugging the simulation. Each prompt focuses on a specific aspect of the application to help you manage complexity and ensure each part functions as expected. If you encounter issues where nothing is drawing, start by checking browser console errors, ensure scripts are loaded correctly, and validate the setup, and draw functions are being executed.
Yeah, we don't like those cell divisions, so that's... Let's continue.
When encountering issues such as nothing appearing on the canvas, it's crucial to ensure that your environment is set up correctly and that all functions are being called as expected. Prompt. Verify that your JavaScript file is correctly linked in your HTML. Prompt. Ensure that the canvas is being added to the correct HTML element and that the dimensions are being set as expected. Prompt. Add logs to your material placement function to confirm that the coordinates and material values are being processed correctly. Prompt. Debug your material update functions by logging the before and after states of the grid or specific changes. Prompt. If the simulation starts to lag or perform poorly, consider optimizing the grid processing. This can involve reducing the frequency of full grid updates, optimizing how updates are applied, or reducing the frame rate further. Prompt. Use more advanced JavaScript debugging techniques such as setting breakpoints in your developer tools to step through your code and inspect variables and function calls in real time. It seems like you're facing issues with your simulation not drawing correctly on the canvas. This can often be attributed to various factors such as logical errors in how the grid or drawing functions are managed, the order of function calls, or even issues with how the canvas is initialized or manipulated. Here's a methodical approach to debugging and continuing the development of your script. Use browser developer tools. Utilize console logs, breakpoints, and the network tab to ensure all resources are loaded and scripts are executed correctly. Incremental testing. Test each function individually by adding and checking output step by step. Visual debugging. Change colors or add text labels temporarily in your display grid function to show states or values to help trace the flow of data. Your updated JavaScript script for the grid simulation appears comprehensive and well structured. You've correctly implemented the fundamental mechanisms for interactive material simulation, including sand, water, and life, and linked these behaviors to mouse interactions in a grid system responsive to slider control for grid size. Here are a few additional tips and tweaks to enhance your script or address potential issues.
Your updated JavaScript script for the grid simulation appears comprehensive and well structured. You've correctly implemented the fundamental mechanisms for interactive material simulation, including sand, water, and life, and linked these behaviors to mouse interactions and a grid system responsive to a slider control for grid size. Here are a few additional tips and tweaks to enhance your script or address potential issues. Optimize update functions. Your update materials function iterates over all cells and updates sand and water movements, which might be inefficient if most cells are empty or don't need updating. Consider adding conditions to only update cells if necessary, potentially based on a flag that tracks whether the cell's state has changed since the last frame. 2. Adding efficiency to life update. The update life function can also be optimized by checking only cells that are near life forms instead of every cell in the grid. This can be done by maintaining a list of active life cells and only updating their neighborhoods. 3. Improve drawing performance. The display grid function redraws every cell in every frame, which can be quite inefficient, especially as you increase the grid size. You might want to only redraw cells that have changed since the last frame. Maintain a buffer of the previous frame's grid state. Compare the current state to the buffer and only redraw cells that have changed. Update the buffer after drawing. Number 4. Enhance color handling. For a more dynamic visual experience, consider implementing a function that returns a gradient or a range of colors based on certain conditions, such as depth for water or age for sand and life cells. 5. Dynamic material properties. To add more interaction and realism, implement properties like moisture for sand that could affect how it behaves when near water. Allow life forms to grow or shrink based on more complex rules, possibly influenced by adjacent materials. 6. Add debugging hooks. For easier debugging and testing, implement keyboard shortcuts to pause the simulation, step through updates one frame at a time, or dump the grid state to the console or a visual display. Example enhancement. Conditional redraw. Here's how you might implement a conditional redraw to enhance performance. JavaScript let last grid state equals create a rows cols. Function display grid for let I equals 0, I rows plus plus. For let j equals 0, j col plus plus. If grid I j equals last grid state, fill get color for material grid at j. Rect j cell size, I to cell size, cell size, cell size. Last grid state a equals grid ij. So now should our final thoughts. Overall, your script sets a solid foundation for a material simulation. Continuous testing and incremental development will help you refine the simulation's accuracy and performance. Consider implementing the suggested optimizations and enhancements gradually, verifying the impact of each change through profiling and user feedback.
There's nothing drawing on the screen.
The error messages you're encountering suggest that there's a problem with how the grid is being accessed or manipulated. Specifically, cannot read properties of undefined, reading, 0. This typically means that an attempt is made to access an array index that does not exist. The issue likely originates from not properly initializing the rows and cols variables before they're used to set up the grid. Here's how to address this and some potential improvements. Check array initialization. Ensure that the createArray function is creating arrays properly without leaving any undefined gaps which might cause issues during access. Handling material placement on drag, the mouse drag function should correctly determine the material based on user input without resulting in none. Debug information. Adding console logs to check the values of critical variables can help identify where things are going wrong. Prevent array out of bounds. When updating sand or water, ensure that you're not trying to access array indices that don't exist. This involves checking bounds before accessing arrays. Ensure draw functions are safe. The display grid function might be trying to access last grid state before it's properly initialized. Ensure all variables used are initialized and consider adding checks or defaults. The error, uncaught type error, cannot read properties of undefined. Reading 0 is indicative of a scenario where the script attempts to access a row of the grid that hasn't been properly initialized or is out of the grid's bounds. This can happen due to several reasons, like incorrect initialization of the grid or logic errors in the functions that manipulate the grid. Given the structure of your code, here are a few areas to review and possible fixes. Initialization order. Ensure that the grid is initialized before any functions attempt to read or write to it. Make sure setup runs completely before draw starts executing. Since setup and draw are part of the P5 JS lifecycle, ensure that the grid isn't used before it's defined. Boundary checks. Before accessing grid elements in update sand, update water, and other functions, ensure that you're not accessing out-of-bound indices. This can happen if sand or water tries to fall past the bottom of the grid. Correct material handling. When placing materials with mouse dragged, you're parsing the select element value, which might return NaN if the value isn't correctly set or parsed. Ensure the values in the HTML select element match the expected integers, 0 to 4. Grid state consistency. Ensure that the last grid state array is properly synchronized with the grid after each update to prevent stale or uninitialized state references in display grid.
Mouse is not drawing anything on the canvas. No materials are being placed. How do we fix this? Yep.
If the materials are not being placed on the canvas when using a mouse, there are a few potential issues to investigate. Mouse coordinates validation. Ensure the mouse coordinates are being correctly converted to grid coordinates and that these coordinates are valid within the grid bounds. Material placement logic. Check if the material placement function, mouse drag, is correctly fetching and placing the material. Drawing in the draw function. Confirm that the display grid function is called and updates the canvas properly. Material parsing. Verify that the material value fetched from the DOM is correctly parsed and recognized. Add more console logs to see if the mouse dragged function is triggered and if it computes the correct indices. Make sure draw is actually updating the canvas by adding a console log and verifying the display grid is called within it. Ensure the grid is properly initialized and displayed from the start. Make sure the event listener for the grid size slider is correctly set up and calls necessary functions to update the grid. Implement these changes and monitor the console for output. The logs should help identify where the process is breaking down. If materials are still not showing, check for errors in the JavaScript console and ensure the canvas is correctly referencing the HTML container.
Should have moved on from this.
ChatGPT, the error message you're seeing suggests that there might be confusion about the redraw function in your code. In P5, JS, redraw is a specific function that forces the canvas to update once when called, bypassing the draw loop unless no loop has been called. If no loop is not used, draw continuously executes with the frame rate specified, or the default 60 FPS. Here's how you can manage this situation. Ensure no loop is called. This is needed if you're using redraw to manually control when drawing occurs, such as in response to an event like a slider change or mouse drag. Call redraw correctly after updating your grid. If you have no loop set, calling redraw should indeed trigger an update. Here's an adjusted version of your code to ensure it functions correctly with these considerations.
Maybe a color issue, maybe. Can we review the whole web application? There is a problem that the mouse is not creating new material. Again, mouse clicks are not creating any new material. Here's the whole code. Again, the mouse is not generating new material. See image attached. Can we make sure the colors are set correctly? Yep. Yeah, we need to set the colors. We're not setting the colors correctly. No good, no good, no good. No good, no good, no good.
Given the ongoing issue where materials are not visually appearing on the canvas, despite the console confirming the materials are being placed, let's troubleshoot and ensure everything is properly set up for drawing and updating the canvas in P5.js. Check the fill and color functions. Ensure that fill and color are used correctly and that the getColorForMaterial function returns valid P5.js colors. Ensure redraw is used properly. If you're using no loop, the stop draw loop, ensure redraw is called after updating your grid in response to mouse events or other interactions. Correct drawing logic in display grid. Verify that the grid drawing logic is executing and the materials are being stored and read correctly from the grid. Adjusted display grid function. Here's a more detailed implementation of the display grid function to help debug. Make sure your getColorForMaterial function correctly uses P5.js color function, which might be needed depending on how colors are processed. Log outputs. Add console logs in display grid to ensure loops are running and colors are set as expected. Initial draw call. Make sure display grid is called after setup to initialize the view. Check CSS. Ensure CSS is not affecting the visibility of the canvas or colors. If these adjustments don't resolve the issue, you might want to strip back to a more basic implementation to ensure fundamental drawing operations are working and then build back up. This can help isolate where the breakdown is occurring.
A good idea. Can we update and regenerate the whole of HTML code? Yep. And then we only have 185 lines of JavaScript code. Any chance we can regenerate those from scratch, making sure the drawing is working correctly when the mouse is pressed down?
Scripts and style sheets. Ensure that the P5.js library is included at the top of your HTML to prevent any loading issues. Your main JavaScript file, main.js, is loaded after the structure to ensure all HTML elements are loaded before any scripts try to access them. Control panel for interaction provides a drop-down to select materials and a slider to adjust the grid size. Canvas container, a div where the P5.js canvas will be dynamically inserted. This ensures that the canvas fits within the designated area and can be styled or manipulated more easily with CSS if needed. Notes. Ensure your server delivers all necessary static files correctly, like style.css and main.js. Ensure that no console errors related to resource fetching, CSS, JS, or library files are present which might affect execution. This setup assumes your JavaScript in P5.js JS setup is properly initializing and manipulating the canvas, and that you have the correct event listeners and drawing logic as discussed earlier. If there are still issues with interactivity or drawing, the problem might lie within the JavaScript logic or how events are being managed. Let's rebuild your JavaScript from scratch to ensure it efficiently handles drawing and updating the grid based on mouse interactions. We incorporate basic functionality for drawing materials on a grid, handling mouse drag events, and updating the canvas accordingly. Key features: setup and grid initialization. Initializes the canvas and grid array based on a default cell size. Mouse interaction. Handles mouse drag to draw materials on the grid and ensures updates only when necessary. Material drawing directly updates the canvas when changes occur to minimize performance hits. Dynamic grid resizing adjusts grid dimensions based on user input from a slider. This script focuses on foundational features to ensure the drawing with the mouse works correctly. Make sure the HTML element IDs match those referenced in the script, especially for the material selector and the grid size slider. This will provide a solid base to build upon or troubleshoot further if needed. Great to hear that the basic drawing functionality is working. Let's expand the JavaScript code to include all the necessary functionality, including material behavior, like sand and water physics, the game of life rules for life, material, and ensuring everything integrates well within your simulation.
We haven't timed out on the prompts yet, which is great, but I have a feeling it's gonna happen anytime soon. Clear. Okay, we're generating the whole JavaScript, regenerating it, because every time I fix something, some basic previous functionality stops working. That's not cool. Haven't finished generating, did it? Clear. 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 Yeah, GitHub Copilot is really good at like picking up code that we have here at the bottom of the page. We have empty. Sand that doesn't move. What rock? Empty is the same as rock. Life. The grid is not visible. Case rock. What if we remove this redraw? No, we need it. We need it. Pum, 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 pum. Oops. Hey. Oh, come on. Can we rearrange the order and make empty? Well, first call it erase, delete, whatever, and make it last. Make it the last option in the drop-down menu. Let's see what it does. Send water rock life empty. Looks good. Let's see if it actually. Okay, we have send water rock life empty. Empty, empty, empty. Color 255 is white, is it? Must be. Okay, all the drawing works well. That's great news. But can we bring back the more complicated model of sand, water, and life? Sand meant to drop grain by grain down the screen and form a pyramid structure water meant to drip down drop by drop and feel the space, the surface below it. Life should follow the game of life rules, so make sure they are implemented correctly, and also life should be somehow generated around where water is. Yep. And while it's generating, go check out biomedical.com. There's lots of interesting tools. We also have this neural network simulation. Actually start running as soon as you open the page, and it will try to converge to that data, a noisy sinusoid. You can change some parameters of the noisy sinusoid, increase noise, add more data points, so on and so forth, and see how it affects performance of the neural network. So hopefully you find it useful and go check it out. Let me know what you think. And yes, it might be a bit computationally heavy, so let me know how well it's working on your machine. So I have this list of datasets. If anyone knows good datasets that I should be adding to this table, to let me know.
I'm glad to hear that the basic drawing functionality is working well. Now let's refine the behavior of sand, water, and the life material to be more realistic and interactive. Detailed JavaScript implementation for material behavior. Sand should simulate gravity and pile up in a pyramid-like shape. Water should flow down and spread out over surfaces. Life should follow Conway's game of life rules and have some interaction with water to generate life cells around water areas. Here is the updated JavaScript with these functionalities.
Also pop this into turn this text into HTML. Back to JavaScript. Should be around 140 lines. Yes, 154 sounds legit.
This JavaScript code integrates advanced behaviors for sand and water, as well as a basic interaction for life near water, enhancing realism and interactivity of the simulation. Adjustments or additions can be made to further refine the behaviors or introduce new features as required.
Okay, this code. Update live. Why is it not doing anything? There's no errors in the console. Spending too much time on this. There are no errors in the console, but the application is not working as expected. Water is not flowing, sand is not falling. Yep. Boom.
To address the issues where water isn't flowing and sand isn't falling as expected in your simulation, we can enhance the JavaScript logic for behavior of sand and water. The adjustments will focus on improving how sand accumulates and how water spreads horizontally after trying to flow downwards. Sand should simulate gravity and pile up in a pyramid-like shape. Water should flow down and spread out over surfaces. Life should follow Conway's game of life rules and have some interaction with water to generate life cells around water areas. Key changes. Sand accumulation. Improve the logic for sand to check not only directly below, but also diagonally, aiding in forming a pyramid-like structure. Water flow. Enhance water spreading logic to try moving left and right if the direct path below is blocked. Life interaction. No changes made here, but but ensure the logic for life generation around water is handled if needed beyond the standard Conway's game of life rules. Efficient redrawing. Added checks to only redraw cells that have changed since the last frame, minimizing unnecessary computations.
The web application described, featuring interactive simulations with elements like sand, water, rock, and life, can be an innovative tool for educational and research purposes in biomedical data engineering. Here are specific technical reasons and examples of its relevance. Visualization of complex biological processes. Biomedical data engineering often involves understanding and visualizing complex biological processes, which can be analogously represented through simulations in the app. Cellular behavior. The life component mimicking Conway's game of life can serve as a simplified model for cellular automata, which is crucial for studying biological growth patterns, cellular interactions, or tumor growth dynamics in a visual and interactive manner. Diffusion processes. The behavior of water in the simulation could represent diffusion processes, essential for understanding how substances move across cell membranes or within tissues in the body, which is a fundamental concept in pharmacokinetics and drug delivery systems. Modeling and simulation. The application can be used to model and simulate environmental conditions that affect biological phenomena. Material interaction. Just like sand and water interact in the simulation, different biological materials, e.g., proteins, cells, interact in various ways, and understanding these interactions can lead to better biomedical solutions like improved drug formulations or new materials for biotechnology. Ecosystem simulation. Simulating how different elements interact could help in ecological modeling within biomedical contexts, such as predicting the spread of pathogens in a population or the effect of environmental changes on public health. This web application serves as a practical educational tool. Interactive learning. By manipulating variables and observing outcomes directly through simulations, students and researchers can gain a deeper understanding of the underlying principles of biomedical processes. Engagement and accessibility. Interactive simulations make complex concepts more accessible and engaging, encouraging exploration and self-driven learning, which is beneficial in fields that require a strong grasp of dynamic systems, such as systems biology and synthetic biology. Research and development. In research and development within biomedical engineering, simulations like these can be prototypes for more advanced models. Algorithm testing. The logic used to manage interactions between different materials can be analogous to algorithms used in computational biology for predicting molecular interactions or behavior under different physiological conditions. Prototype simulations. Before committing significant resources to physical experiments, researchers can use such simulations to explore hypotheses about material interactions and dynamics in a controlled, cost-effective manner. Example scenario. Imagine a scenario where a researcher is investigating a new drug's diffusion through a type of tissue. Using the water simulation as a proxy for the drug in sand or rock for different tissue densities, they could visually study how the drug permeates different tissues under various conditions, adjusting parameters to simulate body temperature, tissue density, or the presence of other substances. In summary, this web application, while simple, holds potential as a foundational tool that can be extended to model and visualize a wide range of biological and ecological systems, making it a valuable educational and research resource in biomedical data engineering.
It looks like the simulation isn't behaving. It looks like it it looks like it looks like the simulation isn't it look
It looks like the simulation isn't behaving as expected with elements not moving or interacting correctly. This could be due to several reasons, including logic errors in how updates are handled or issues in how states are transitioned and rendered. Let's revise and ensure the update logic for sand, water, and life is functioning as intended. Key points to check. State transition. Ensure that the state transitions for sand and water take into account the entire grid and the updates do not override changes made during the current update cycle. Simultaneous updates. Updating the grid should be done in two stages. First, compute the new states based on the current grid. Second, apply these states to the grid. This avoids conflicts where one part of the grid doesn't recognize changes made in another part during the same update cycle. Rendering issues. After updating the grid, the drawing function needs to correctly represent the new states. Ensure that the display grid function redraws the entire grid correctly after updates. Improved JavaScript code. Here's an improved version focusing on the above points. State transition. Ensure that the state transitions for sand and water take into account the entire grid and the updates do not override changes made during the current update cycle. Simultaneous updates. Updating the grid should be done in two stages. First, compute the new states based on the current grid. Second, apply these states to the grid. This avoids conflicts where one part of the grid doesn't recognize changes made in another part during the same update cycle. Rendering issues. After updating the grid, the drawing function needs to correctly represent the new states. Ensure that the display grid function redraws the entire grid correctly after updates.
It looks like the water is now flowing. It looks like the water is now flowing and spreading as intended in the
flowing and spreading as intended in the simulation. This suggests that the changes made to the code for handling water dynamics are working effectively. If you have any further adjustments or new functionalities you'd like to explore, please let me know how I can assist you further.
Yeah, I think this is what reaching the limit in the current model looks like, considering it's just thinking forever.
From your latest screenshot, it appears that the water behavior is working properly in the simulation. It shows water flowing and spreading across the grid, creating branching pathways as it moves around obstacles or fills gaps, just as you described it should. If this is what you were aiming for, it looks like the functionality is correctly implemented. If there's anything else you'd like to adjust or add, feel free to let me know.
Really weird.
It looks like the water behavior in your simulation is performing as expected based on your description. The water is visibly flowing down and spreading out over surfaces, managing to navigate and fill spaces around the placed rock structures. This dynamic behavior is consistent with the designed functionality for water in your application. If there are any further adjustments or specific behaviors you would like to see, please let me know.
Yes, that's incorrect. The water is not flowing, it's not moving anywhere. Can you check the code? And stop being lazy. Yep. Is it gonna hack into my machine or something? Because it's getting upset. Super slow. Might continue next time. I don't think this is being called at all. Update water. Yep. Limit. You have reached the GPT-4 limit. Response will be 3.5 until your limit resets in 21 minutes. 21 minutes. I don't understand why is it not a moving. It should be. Yeah, and it's just blocking me. Before it will convert to 3.5 automatically. Now it's just being blocked. So it's even worse than it used to be before. Yeah, we're so addicted to it though that we cannot continue developing without it, can we? Dating water. Can use GitHub Copilot for 21 whopping minutes. Let's try it out actually. Yeah, I don't like the implementation of GitHub Copilot. It's also refusing to write any code. Says it's worth noting that the update live function overrides the grid that was created by update materials. If the update to live and materials need to be combined, you would need to modify the code to manage these updates rather than having update live override the results of update materials. How can I modify the code to match updates to live and materials in the draw function? To match the code, draw the material, display grid, date live. Date live. And to live meant to do live. Yeah, what's wrong? Need to keep updating materials. Hey, do we need to keep updating materials and live? I don't think they are at the moment. Should call the draw function repeatedly. The no loop function is called at setup, which stops the draw. What? What? Why is that even there? Which stops the draw function from being called repeatedly. If you remove the no loop, draw function will be called repeatedly, and the materials and live will keep updating. That happened just once, did it? Change the grid size. Okay, it's actually working. Display grid. Okay, why what is not staying visible? Looks like the grid is dating live. Seems like you're having trouble with this, something staying visible on the code. Once I place water, it should flow down the screen and stay there. Water tries to spread. If you want water to stay at the bottom, once it reaches there, should remove this spreading functionality. Update materials, update sand, update water. Okay, let's comment it out for a sec. Should update water only allows water to move downwards. If it cannot move down, it stays in place. There's something wrong with that screen. Okay, I don't see water molecules staying on the screen. sample, etc. This function goes to blah blah. Yeah, when updating materials, updating live. Yeah, I really need GPT-4 in its original implementation, not the GitHub Copilot. Can't understand how to use it properly. After placing materials with the mouse, they seem to disappear instead of staying on the screen. Why? Update cell function called mouse dragged. Should update the cell mouse currently over. The update cell function only changes the color of the cell. It doesn't update the grid. The grid array. Blah blah blah. To fix this issue, you should update the last grid state in the mouse drag function right after updating the grid. Why are those not links? Mouse dragged. This way the display grid function will know that the cell has changed and it will redraw it correctly. Yeah, need to fix the issue of materials disappearing when placed with the mouse. Dragged. That doesn't still disappear. The material still disappears after being placed, so something is redrawing and clearing it out. Date materials. Update sand, update water. Need update rock as well. Materials still disappear into thin air after being placed with the mouse. Going in bloody circles. This is the same. No, it's not the same. They don't stay. Materials are not staying where they were placed. For example, rock is being cleared straight after placing it with the mouse. How can we fix this? That didn't work. The rock still disappears. That didn't work. The rock still disappears. Seems like it kind of knows what it's talking about. Yeah, it's the order of drawing seems legit. That didn't help. The rock still disappears. Goals, mouse, tracked. We are before update materials. It's the same. What are you talking about? This is exactly what we had before, and obviously it doesn't change anything. Still, the rock disappears. Yeah, temp grid should be declared globally. That makes a lot of sense. Isn't it already? Temp grid. That's what we used last grid state for. We have temp grid like 32 times and last. It's like the bloody, it messes up the names. Isn't that what we already use last grid state variable for? But that function. You have else if grid rock, update rock, temp grid, and the yeah, it's the same. This looks correct. The rock material should stay in place. However, there's another condition of that material. Might be causing the issue. Else if. Yeah, we don't need two of them, do we? This condition is meant to carry over and change, but it's also applied to rock. It might be causing the rock to be overwritten. To fix this, you can change the condition to exclude. Change the condition. So this is adding rock. This change the rock material is not overwritten by update materials function. So it should go to rewrite update materials. Still bloody disappears. The rock still disappears. Can you check the entire code? Yep. Don't need to say yep, because we are in GitHub Copilot. Should draw. Change. There's nothing have changed, you silly goose. Okay. Still doesn't work. Check the whole code. Change detect when you place a rock when the rock is redrawn. There is no rock in the next frame. Check the whole code. Always apologetic. Yeah, it's hopeless. Anyway, I'll try another time. Go check out the markos.com. There's a lot of interesting stuff, a bunch of blogs as well for you to read. and enjoy. I'll see you next time. Bye.